For each pipeline, an erosion control plan is required, and the pipelines require erosion control devices such as silt fence, water bars, filter socks, and rock check dams. In this next section, we're going to talk about the different devices that are used on the construction plans and in the field for control of erosion on the site. The first device is the first thing that's always installed on a construction site. It's called a stone construction entrance. It's a temporary stone stabilized pad located at points of vehicular ingress and egress on a construction site. The purpose is to provide a stable entrance and exit from a construction site and keep mud and sediment off public roads. The gravel, the stone on the construction entrances pulls the mud off the tires of trucks and vehicles before they enter into public roadways. It's a safety issue to get mud on roadways. You can call VDOT or the local sheriff to complain about mud on roadways from construction sites. It's a major issue. Pad dimensions for the stone construction entrance are a minimum length of 50 feet with a geotextile fabric placed between the stone fill and the earth's surface below the pad. The pad should extend the minimum width of 12 feet and the gravel should be placed at least 6 inches thick. Maintenance, the entrance should be maintained in a condition that will prevent tracking or flowing of sediment onto public right-of-ways. And then if there is any mud on the right-of-way, on the public roads, the mud has to be removed from the roadway immediately. As you can see on the left-hand view of the slide is a construction entrance that's well maintained. The gravel is thick and it's wide and it goes back far enough. On the right-hand side, you'll see a construction entrance that has a trash rack, or a wash rack as it's called, where the tires of the vehicles can be washed as the trucks leave the construction site and before they enter the public roadway. Another device that is very commonly used on the pipeline projects is a silt fence. Silt fence is a temporary sediment barrier made of porous fabric. It's held up by wooden or metal posts driven into the ground. In the picture on the right-hand side of the slide, you'll see an example of a super silt fence where we have chain link fence that is installed behind the filter fabric to reinforce the filter fabric. On this view, you can see that there's been a lack of maintenance on this particular area. The sediment is almost all the way up to the top of the silt fence. It should have been removed by now. The requirement is that you cannot exceed half the height of the silt fence before you have to maintain it. Proper installation of silt fence. One, you set the post, excavate a 6-inch deep trench upslope along the line of the post, and it has to be perpendicular to the flow of water. Then you staple wire fencing to the post. Then thirdly, you attach the non-woven filter fabric to the wire fence and extend it into the trench. And last, you backfill and compact the excavated soil uphill. Some of the problems with silt fence that we've seen are overtopping, sagging, or collapse of fences caused by the drainage areas too large or too much sediment accumulation allowed before clean out. Another item is collapse of fence due to high velocity of runoff or undercutting of fence caused by the approach is too steep on steep slopes. Sagging or collapse of fence caused by fence not adequately supported. undercutting of fence caused by the bottom of fence not buried properly. Sagging collapse or undercutting of fence because the fence is installed across a drainage way. Drainage ways will blow out a fence immediately. They are not built for being installed across drainage ways. Water runs on both sides of the fence. The fence is installed vertically or at right angles to the contour instead of parallel. The fence should never be used as a check dam or in concentrated flow paths. Inspection and maintenance is required after every major rainfall event. They should be inspected routinely and after rainfall events to determine whether they need maintenance because they are full or damaged by construction equipment. In the pictures on the right-hand side, the upper right-hand side, you can see where the silt fence has not been maintained, that it needs to be removed and replaced, or the sediment has to be pulled out. On the bottom slide, on the right-hand side, you'll see a silt fence where the runoff is running along the upper side of the silt fence and eroding away the bottom of the silt fence. On this slide, you can see the silt fence has a very good insulation. It's held up, there's no sagging, it's been buried on the uphill side, and it works. In addition, they've got grass growing, which helps a whole lot with preventing sediment coming down into the silt fence. On these two slides, you can see there's an obvious need for maintenance. The silt fence is collapsed on the upper left-hand side. On the bottom right side, you'll see where runoff has created a ditch below the silt fence where it has undercut the fence and running freely downstream below the site. One of my favorites is where they install the silt fence below a drainage channel. As you can see, there is almost no silt fence left because the washout has been so severe that it overwhelmed the silt fence and buried it. Here's another view, that same area, and you can see the area below the silt fence that collapsed is also buried. There's no maintenance there. It needs to be replaced. In this case, they probably need to put in a super silt fence. And this is a super silt fence. It's a combination of chain link and synthetic woven filtration fabric. Super silt fence is used to control extreme erosion or to protect slopes, steep slopes, up to 18 or 20% slope. The third device that's used on pipeline projects is temporary right-of-way diversions, otherwise known as water bars. A water bar is a ridge of compacted soil or loose gravel placed across the disturbed right-of-way. The purpose of this practice is to limit the accumulation of erosive volumes of water by diverting surface runoff at specific intervals. The primary purpose is to reduce the area, the drainage area that's coming down into the diversions in order to decrease the drainage sheds so that there's not so much water coming down off of a site. If you have large drainage areas, it's much harder to control the erosion. Water bar dimensions, usually they're built 18 inches minimum from channel bottom to top of settled ridge. Side slopes 2 to 1 or flatter, 3 to 1 or flatter where vehicles cross, and at least 6 feet minimum width on the bottom. You can see the cross sections, the isometric view on the right-hand side of this slide. Here's another detail view. Right-of-way diversions can also be built of VDOT #1 coarse aggregate instead of dirt, compacted soil. Typically, they're earthen structures. On this slide, you can see is an isometric view of the water bar itself in relation to the construction right-of-way. The water flows down the right-of-way into the water bar and then off the site, off the water bar, into an outlet structure. The purpose of the outlet structure is to reduce the energy from the runoff so that it won't create erosive forces below the water bar, thereby creating gullies, which create more erosion downhill. Another device that is commonly used on pipeline projects is compost filter socks. And compost filter socks are tubular sediment control devices typically used for sediment perimeter control of sediment on and around construction activities. Compost filter socks trap sediment by filtering runoff as it passes through the compost filter socks. Here's a couple of examples of compost filter socks. They are installed downslope of disturbed areas requiring erosion and sediment control and filtration from runoff. On the left-hand side, the lower side, you can see where the filter sock is working very well. They have mulched the area above the filter sock. They have staked it down properly and it's working. On the upper right-hand side photo, you'll see another double layer of compost filter socks on the upper side. They've staked it down properly. The drainage areas are small to the filter sock, and they actually have installed a perimeter control on the lower side, which include filter socks and silt fences. They're in pretty good shape here. They have also put mulch down, which also helps reduce the runoff. On the bottom right-hand side, you'll see a filter sock that has not been properly installed or maintained. The filter sock itself is being overwhelmed by sediment. It's too close to the bottom of the slope, and it has not been maintained properly. Rock check dams, you will see some of these on the construction sites for the pipelines. They are constructed from large stone for small drainage areas up to 1 acre. They can also be constructed from small riprap for drainage areas up to 5 acres, with an upstream layer of small aggregate for filtering. They're commonly used in drainage ditches. You see them on highway projects. The photo on the bottom right shows a series of rock check dams installed across the drainage way that is catching sediment as the runoff goes downhill, and they appear to be working very well in this case. Trench plugs. Trench plugs are used to prevent erosive runoff from velocities from developing in the trench. They keep the drainage areas small and break up the runoff as it goes downhill in the trench, the pipeline trench. The trench plug serves to form a catch basin for runoff in the trench, trapping the soil and preventing it from being washed out of the trench. The two photos on the right-hand side show you a typical trench plug. It can be built of different materials, and there's different details for construction of trench plugs. Here's another view, trench plugs for a pipeline. It can also be called trench breakers. After the pipe is buried, these are removed from the trench. Temporary swells are excavated drainage channels which prevent runoff from entering disturbed areas by intercepting and diverting it to a stabilized outlet, and to intercept sediment-laden water in disturbed areas and divert it to a sediment trapping device. You can see the view on the right shows a temporary swell with check dams again installed across it to catch the runoff and sediment as it comes down the hill. Temporary seeding is required. Temporary seeding is a soil stabilization practice involving the establishment of temporary vegetated cover to reduce erosion on construction sites that have disturbed areas that are temporarily idle. And what we mean by idle is where no soil disturbing activities occur on that portion of the site for 14 or more consecutive days, for 2 weeks. And again, I want to remind everyone the most efficient way to control erosion is to establish vegetated cover. Put grass down. Grass is the best practice to prevent erosion. After seed emergence, check for vegetation, bare spots or sparse areas. If the seeding fails to grow, it may need to be reestablished to provide adequate erosion prevention. It's required that 70% of an area be seeded, have grass growing in order to meet the requirements. If it's less than 70% of the area that has grass on it, then it needs to be reseeded.